Eastern Regional Manager here at Fowler Precision. Today we're on board the Mobile Tech Center down in the Eastern United States. We're on site at a customer's location where they brought out a part for a specific application they wanted us to address. The specific application in question is they're looking to capture the true position based off of the outside diameter, which is their datum A. So the true position relative to datum A here on the part on the stage here. So I've drawn up a program. I've used a couple different lighting settings just for your view to see some different capabilities that the machine does have. And we'll go ahead and run this program, let you take a look at what we can do. So I'll hit this play button here, which is going to bring up my program tree, and I'm going to hit the run button, which is going to bring me a little countdown. It's going to tell me I'm going to save all the data for SPC analysis. Once that's complete, it will go ahead and start measuring the part. As we measure this part, as I said, we are going to use a couple different lighting settings merely for this video's sake. As we pass through these different features, we will be drawing up the dimensions that we have requested. Once it's all completed, we'll be able to review some reports that the machine is capable of spitting out. Now our program is complete, and we've been given a pass with our quick summary report. I'm going to X out of that, and I'm going to bring up a greater detail. So what I want to do is hit my print button here, and the first print I want to see is going to be a graphic detail where we've actually created a print. And if you look at this print, you'll notice that we have notated datum A, and we have our true position relative to that specific datum. I did pull up a bunch of other dimensions just to show you some different features that we can measure, but this is the most important part to the customer in question. I'm going to X out of that now, and I'm going to go back to that reporting page. I'm going to hit tabulated dimensions, and I'm going to go ahead and say clear report, add report, and when I print that report, it has now interrogated the file in question with our nominals, our actuals. It gives me the dimensional limits, the dimensional error, excuse me. We have our upper and lower limits with a pass-fail classification. We have our geometric limits, so we have our actuals as well as those geometric limits, and another pass-fail classification. Of course, if anything on this fails, the part is a fail and it needs to be reviewed. I'll go ahead and X out of that now. If I look at any dimension by right-clicking on the dimension window, I can go to a further SPC report. You see a history of this feature here, and you start to see some SPC data and some graphs. So what I want to do is, instead of just graphing this specific feature that I have open, I'm going to hit my Excel spreadsheet icon. I'm going to say add all of my dimensions and then show me the report. If I go down to the corner here and it's opened up Excel, you can see it's dumping all of that information for every single feature into my Excel spreadsheet. Once it's finished syncing all of this information into Excel, you'll see it has completed this report, and we can see an SPC report for every single feature for every time that feature has been measured. It's a really nice, quick, easy way to get a lot of data out of this type of system. I'm going to close that out, and we won't save it because we don't need it quite yet for this particular situation. So just to kind of conclude, we have been able to capture this process, this measurement with this particular part on our smallest stage, which is a 5 by 10 inch stage, but we do have larger systems that can go as big as 1 meter by 1.5 meters. So I just want to thank you guys for taking a minute to look at this video, and if you guys have any questions, feel free to contact your local Fowler representative. Thank you.
Working on